What's up, everyone? This is Nat Maven. Today we will talk about the Cisco Nexus Dashboard Orchestrator with ACI Lab. What is Nexus Dashboard Orchestrator? Nexus Dashboard Orchestrator allows us to interconnect separate Cisco ACI sites, Cisco Cloud's ACI sites, Cisco Nexus Dashboard Fabric Controller, NDFC sites, each managed by its own controller, Epic cluster, NDFC cluster, Cloud Epic instances in a public cloud. The on-premises site can be extended to different public clouds for hybrid cloud deployment, where cloud-first installation can be extended to multi-cloud deployments without on-premise sites. The Cisco Nexus Dashboard Orchestrator (NDO) can be deployed through the Cisco Nexus Dashboard, which provides a single automation platform to access data center networks operational service and tools. The Nexus Dashboard Orchestrator provides few main functions. First is a single pane of glass for administration and orchestration of multiple networking fabrics for both Cisco ACI and NDFC. Automation of the configuration and management of inter-site connections across an IP backbone for both Cisco ACI and NDFC. In each site, it maintains consistent multi-tenant policy across multiple sites, which allows the IP mobility, disaster recovery, and active user cases for data center. Capability to map the tenant application associated network to specific availability domains within the Cisco multi-site architecture for both Cisco ACI and NDFC. The NDO Nexus Dashboard Orchestrator can be deployed on-premise or on the cloud, AWS or Azure. The inter-site control panel here, endpoint reachability information is exchanged across using MP, BGP, EVPN control panel. This approach allows the exchange of MAC and IP addresses and information for endpoint that communicate across site. The MP, BGP, EVPN session are established between the spine nodes deployed in separate fabrics that are managed by the same instance of Cisco NDO. As discussed, we will talk about the multi-site overlay control panel later. Inter-site data panel allows communication L2, L3 between endpoints connected different sites, achieved by establishing a site-to-site VXLAN. Tunnel across genetic IP network that interconnects the various sites. The IP network also has no specific function requirements other than reach capability to support the routing and increased MTU size. So that's given the overhead from the VXLAN encapsulation. After we log into the NDO, the first thing we're going to do is to go to site, and we'll add the San Francisco site and New York site. You just need to put in your fully qualified domain name, IP address, and main username, password, and it will be able to add a site here. Then what I would do next is go to the APIC of the San Francisco site and go to Cisco ACI Fabric Setup. We're going to set up the BGP. BGP we here we already set up is to give it AS number 65001 is San Francisco site, and it pick up all the spines. Spine 1, spine 2 all configured, all good. And okay, that's it. We'll then go to set up my physical domains. L3 physical domain name is Multisite external L3 domain. So I'll do the same thing to the New York APIC. Or double check if we have all that set up. The BGP is having its AS number 65002 is the AS number for New York's APIC site, and we'll configure two spine. It's two spine 1 and two spine 2. So that's exit. We'll go to fabric, access policies, L3. Well, of course, we need a multi-site external L3 domain. Now we have the size, the NDO, and we'll now go to orchestrator. We have set up the BGPs. Go to site in each APIC, and we'll measure each of the site. So let's pick a San Francisco. Click manage it, site 1. Click New York, site 2. Now I'm seeing the two sites in manager state. I will go to infrastructure and go to site connectivity. Now I'm seeing two APIC sites, site San Francisco, site New York. We'll then hit config. We'll leave the generic settings. Click San Fran, spine 1. We'll first add a port. The ports we're going to add. So what we will do here is to put on port S1, S2, spine 1, spine 2 in San Fran site, and New York site, spine 1, spine 2 on port 5/32. Each one 5/32 will give an IP on each port, and it's IP network for inter-multi-site connections. Go back to dashboard. We're going to put the port to 532 IP address 10.1.0.1 32. MTU will increase to 9216. OSPF will be enhanced. Will be enabled, and here policy will pick up the default policy right here. No authentication, and click save. Go to New York and still appear to the spine 1, add a port 5/32 10.2.01 31. Same thing. Enable SPF, pick default one. No, now for authentication, save it. Now we have port config on spine 1. Go to San Francisco. Check spine 1. Go to peering. We're going to toggle the button to enable BGP peering. Now enter the IP address in the BGP EVPN route ID for spine 1. Site 1 is San Francisco, so we'll enter 10.1.100.1. The inter-site control panel, the endpoint reachability information, is exchanged across the site using MPBGP EVPN control panel. So this approach allows the exchange of the MAC and the IP address information for endpoints that communicate across the site. MPBGP EVPN sessions are established between the spine nodes deployed in separate fabrics. After that, click deploy. go to New York site, spine 1, enable BGP pairing. New York site ID is 2, so then 10.2.100.1 and click deploy. Here saying the BGP pairing is a toggle, and we're ready to configure the spine 2. Go to San Francisco site and add a spine 2. Port ID still 532 10.1.03.31. Same thing for the OSPF MTU. Click save. Go to New York, spine 2, add a port 532 10.2.03.31 9216 OSPF. Pick a policy, save, and go back to New San Francisco site 2. Toggle the BGP pairing. We're going to enable 10.1.102. Click deploy. New York site, click spine 2, BGP pairing, 10.2.102. Click deploy. Now I'm seeing is San Francisco site, spine 1, the ports and IP, MTU, BGP pairing, same thing here for spine 2. On spine 2 we have the ports, the IP, MTU, and BGP peer route ID. Go to New York, spine 1, ports, IP, MTU, EVPN route ID. Same thing for spine 2. The configure next is go to San Francisco, click the part 1, and it will be selected. What we're seeing here is we're going to enter the corporate IP address for overlay unicast tab field. Under part 1, on San Francisco, we're going to enter the overlay unicast tab 10.1.100.100. Back go to New York. Click tab part 1, 10.2.100.100. Go back to San Francisco. Check the entire San Francisco site. Multi-site check. The overlay multicast tab, San Francisco 10.1.100.200. OSPF 0. Gonna be a regular area. The external router domain, we're gonna pick the domain we created before. And we'll click deploy. Now we configure the site with overlay mode type. Multi-site is enabled, OSPF, external router domain. They're all configured. On the part, we configure the overlay unicast tab. Well, I can move on to the New York site. Check the part. I'll configure the unicast tab. Go to the site New York, enable multi-site. The BGP autonomous system numbers are automatically populated, and we just need to enter the overlay multicast tab 10.2.100.200 OSPF regular external router domain, which is what we created before. double check the port, the site, the port. So let's talk about what all these IPs are. Hook the information icon. It tells you the overlay multicast type is for intersite L2 BOM and L3 multicast traffic. What does that mean? It is PIP, the primary IP. The MV interface update source is locally meaningful and must be advertised out to the interconnect multi-sites due to the BOM source update address. So if you want to go to other site, and this IP address will be used for BOM traffic, POM traffic forwarding, and it's the update source. And go to the pod, we have the overlay unicast tab. That is the BGW, so Board Gateway VIP. In the same site, it's gonna have maximum 4 BGW will share the same unicast type for VIP. Activate it. Now I'm seeing the line is connected between the San Francisco and New York sites. Next, I'm going to add the multi-pod data panel type configuration. Log on to my San Francisco epic. Let's go to tenant, infrastructure tenant. On the policies, find the protocol. We're going to find the fabric external connection policies. Add a community, extended AS2-NN for column 5, column 16. In the work panel, I will double click part 1. Here, check part 1, select part 1. Unicast. Here we're going to add the created data panel type subnet. So it's going to be 10.1.200.200 32 update. I'm going to submit it. Follow after that, so we're going to find networking, L3 out. Then we go to L3 out in the site, indicates that infra L3 out has been successfully configured on the epic for the site 1 at San Francisco. The object for L3 out also includes a small crowd icon. All ACI object configured by NDO will include this icon. The next step is to repeat all the steps for the New York site using New York values. So I'll go to navigate New York APIC and the tenant. We'll find all tenant infra. We'll find L3 out. Also creates the automatically by NDO. And go now check the policy to the protocols. Let's find out fabric external connection policies. Here we go. I'm going to enter extended column AS2 and 4 5 column 16. And here we will find out the port number It's already created a multi-site unicast data pattern tab. It's also already created for us. Scroll down a little bit, so we're going to let's go ahead to submit this. Let's go ahead to check network L3 out. L3 out already created. That's showing up here. Afterward, you will find the remote site is also set up under Fabric Extend Connection Policy. It's in New York, APIC. If I go to my San Francisco APIC, see the remote site to site 2 in San Francisco, which is site 1, is already configured. And next, we'll create an NDO tenant. We'll create a tenant in the Nexus Dashboard Orchestrator NDO that will be deployed across both sites. This is a greenfield tenant that doesn't currently exist at any site, and the configuration will be pushed to both sides at the same time. So in the Nexus Dashboard Orchestrator NDO, we'll select Application Management. On the tenant. In here, we'll add a tenant. Name is going to be Pursue Pursuitical. And we'll select both San Francisco and New York and click Save to push the tenant configuration to Apex. Let's go ahead and return to Apex San Francisco and Apex New York. We're going to verify the pursuitical tenant is created on both fabrics. In either San Francisco or New York APIC, we'll click the pursuitical and proceed to the APIC window for pursuitical. In the tenant object includes the crowd symbol indicating this object has been configured from NDO, and APIC GUI will also display a message to the effect. We'll next explore ACI Multisite use cases. This app will have 4 common multi-site use cases. So first one, layer 3 owning communication across sites is intra-tenant and intra-VIF. Use cases will show L3 communication across sites. The tenants and VIF objects will be stretched across the sites, but the bridge domain, subnet, the EPG configuration will be local to each site. In each site, we'll create a web bridge domain. App bridge domain contains EPG web and EPG app, each in Francisco and New York. Owning the VIF and sites are common tenant in cross sites. That's in the NDO actuator configuration. We're gonna choose navigate application management and go here, click schema. First we'll add a schema. The new schema name will name it as L3 strat schema. L3 stretch schema. Click save. The schema contains templates. The templates that are associated to one or more sites and are used to define objects that will be stretched between sites and will remain site local. Let's click add new template to add template, then select the template type dialog. I will select the ACI Multi-Cloud and then click add. We'll change the template setting and display name from template 1 to SF and NY template. In the template setting, in the select tenant drop down, we'll select the protocol. We'll click the create object and then VIF. In the display name field, we're going to enter VRF1. Because the object name's template will be stretched across both sides, it must be associated with both sides. In the action, we'll select site association. Check both sides, click OK. When configuration is added to the NDO, there is a Save Schema button and Deploy to the Site button. Save the template configuration saves it to the NDO database, but it does not make any changes to the apex. Only after selecting Deploy to Sites is the configuration change pushed to the apex. At this point in the configuration, we have added the templates and created the VF, but they have not saved nor deployed the configuration. Let's click the Save Schema to save the configuration to the NDO without deploying to APIC. And we'll click Deploy to Sites. Then we'll show a window will appear showing which changes will be deployed and which site. I will name it as SF only. And I'll select the tenant protocol, save. I'm going to create application profile, name it. We're going to name it as web app. Be careful the capital small case. Then we'll click add EPG. The EPG will be a web, capital W. We're going to scroll down for the bridge domain to associate the web EPG to a bridge domain. We're going to create a web bridge domain called web-bd. The default bridge domain setting will appear on the right side panel. This bridge domain will not be stretched across sites. Now, click web-bd. I'm going to pick a VRF1, and we'll uncheck L2 stretch. Click yes. When the L2 stretch box is unchecked, the option to add a BD subnet is removed. This is because the bridge domain becomes a site local configuration. The site's local configuration will be covered in later. We'll select the VRF1. We did, and this VRF will create in San Francisco and New York template. And we'll select action, click set association, will apply to San Francisco. This associates the template to only San Francisco site. Click OK. To close the window, and then we'll save the schema. Let's then click deploy to site. The NDO shows the changes that are being pushed to San Francisco, and we'll click deploy. We'll wait the successful deployment messages. Now, site local configuration changes are not deployed in the template view. They are visible only in the site view. Select the template property, and then San Francisco in the vertical menu to view the site local changes being synchronized. Bridge domain and EPD. We'll then select the web bridge domain. Scroll down. The next step will be turn on the site L2 stretch, so I can add a gateway IP and add it 10.1.1.254/24. Click OK. At the top, we'll save schema, and we'll select the view San Francisco only template and click deploy to the site. The EPGs are associated to the domain. The domain association and the static path binding configurations are also down from the NDO. This will always be a site local configuration task and will be configured from selecting the site, just as what was down for a bridge domain subnet. This lab we will not be configuring and domain, but to be aware that this configuration is always site local. Let's then repeat the previous steps to create a New York only template associated to the protocol tenant with the new tenant we'll be creating. Add a new template. The new bridge domains app-bridge domain. Check the bridge domain. Select the VF. Then we'll add bridge domain subnet for the app bridge domain. So at a point, both sides have been configured with tenant called protocol and the application profile called web app. A web EPG and bridge domain has been configured in San Francisco. In app EPG bridge domain has been configuration in New York. There's no communication at this time between sites, and the web bridge domain subnet in San Francisco is not known to New York. There's a vice versa for the app bridge domain in New York. Does not be known to the San Francisco site. So a contract is required in order to allow communication between sites and to advertise endpoint IP address information between sites. Since this contract will be used by both EPGs, and we will configure it under San Francisco and New York template. Before doing that, we still needed to save the schema. We're going to associate only to the New York site. Then we'll deploy it to the New York site. The contracts are common, so we'll go to San Francisco, New York template in the vertical menu, and we'll select Create Object. The object created with the contract will enter the contract name is web to app or small case in the display name field. We'll then create an object that against the selected filter, then the display name field, and we'll enter ending. Click the Add Entry in the name or then type ending and click OK. And scroll up to Web App. We're going to add a filter in the drop down menu. Select the ending. Active for action is permit. Click OK. Next, we're going to deploy the site. The changes were made. Filter and contract. Now I will add the web to app contract provider contract to web EPG in the San Francisco only template, and web to app consumer contracted to the app EPG in the New York template. This will enable the application tiers to communicate between sites as long as they are deployed in the same tenant. So let's go on, select San Fran only. I'll click the web EPG. Scroll a little bit down here, add a contract. The contract we'll be adding here is select the web to app. The type will be the provider, San Francisco. In here is gonna be a provider. This will be provider and a consumer. Okay. And in the vertical menu, we have back here we have San Francisco only. I have added provider type of contract to web EPG in San Fran only template. Now in the vertical menu, we're going to select New York only template, check app, and we'll scroll down, find contract. This contract will be the consumer to New York only. Let's go on, save schema, click deploy to the site, click deploy. We'll do the same thing to San Fran only because it's already showing out of sync. Click deploy to the site. It tells me that contract is going to be deployed. Let's go on, log on to my San Fran Epic. We're then going to navigate to tenant, and we'll find the NDO created pseudo-code tenant. Then we'll find a little clouds on the AP and EPG. We'll find EPG is created, and contracts also created associated. Go up, check the web app. Topology shows the presence of a contract that allows the EPG to communicate. Next topic we'll talk about is the one and another ACI multi-site use case. L3 only communication across sites and VF, but it's shared services. So this use case is similar to the one completed to enable L3 communication across sites. The difference is the use case provides shared services access to resources that are deployed in a site as a part of a dedicated shared VF bridge domain EPG object, as shown in this diagram. In New York Epic, we'll be creating a shared bridge domain, and a EPG DNS will be created. The contract web to DNS will allow the bridge domain web app for EPG web to consume this DNS EPG service deployed in New York, and the VF will be a shared VF. We're in this case creating a new VF bridge domain and EPG for DNS service. So let's navigate to NDO. We'll select this application management, and we'll select the schema. Check L3 stretch schema, and we'll navigate to New York only because we're creating a new VF. We'll create new VF. Name it will be the shared VF. Then I'll be creating a new bridge domain. The bridge domain will be shared bridge domain. We're going to select the share VF associated with these shared bridge domain. And scroll down to create a bridge gateway IP 10.10.10254/24. Click OK. Check edits again to make sure you have checked the shared between VFs. Click OK. Now we'll be adding a new EPG. The new EPG name will be DNS, bridge domain or shared bridge domain. And because the EPG provides service to other EPG, I must remember to add subnet information and the EPG at the site level. Click add subnet. The same subnet will be checked here. Is shared between VF and no default SPI gateway. Both are to be checked. So the purpose of defining IP subnet information under provider EPG DNS is to enable necessary VF route leaking function between shared VF and the other VFs are accessing the shared service. The IP subnet that is configured at a bridge domain provides the default gateway services. So it is important to select the no default gateway flag. Next, we'll be creating the Web to DNS contract and ensure that DNS EPG provides it. So in the view, navigate to San Francisco, New York template. It will be creating a contract. The contract name will be Web to DNS. So the tenant scope will be a tenant and future. We'll add to the ending default actions permit. That's fine. And to push the configuration both San Francisco and New York, we will click save the schema, deploy to the site. Now a new contract is provided. We'll then find out the New York template. Click DNS, add a contract. This time will be wrapped to DNS. Select provider, click OK. To push the configuration to New York, well, check deploy to sites, and this tells me what would be provisions. A new EPG, DNS, bridge domain, shared VF, deploy. Now we configure web EPG to consume the web to DNS contract. We're going to navigate scroll vertical view, go to San Francisco only templates, and under EPG, click web, and we'll find a new contract to add. This new contract we'll add is web to DNS. This will be consumer. Click OK. Now I'll push the new configuration. I'll click deploy the site. Click deploy. Now let's verify the configuration I deployed to the San Francisco APIC. Let's log in. Click tenant and a pseudo call tenant. We're going to expand the application profile for app. And we're going to check topology. I'm going to see it here is the web app is consuming the web to DNS contract, and DNS app is providing this contract. Go to my New York epic. I can see the same topology diagram here. I'm also seeing the application EPG, app and DNS were created by NDO. The next use case we'll talk about is the IP mobility core site. It is a stretched bridge domain without bomb flooding. In this use case, the requirement is to have IP mobility core sites. So it's the same bridge domain, but without enabling bomb flooding. This use case is typically for disaster recovery sites where there's not a requirement for mobility, or we call vMotion, a core site, but we allow the application to be brought up at the DR sites without having to re-IP application servers. So server into the site. The suppression of a bomb flooding across sites provides more resilience across sites, since a problem like a broadcast storm hitting site 1 won't be able to propagate to other sites. You won't propagate to other sites. A new bridge domain we call a database. There's gonna be a database bridge domain. It will be created, provisioned to San Francisco and New York sites, and enable use case on the tenant pseudo has tenant, and the bomb tracker is banned. I'll still go to my NDO window, and we'll be insert the San Francisco and New York template. We're creating a new object, of course. That's gonna be bridge domain. The bridge domain name we're gonna say DB bridge domain. The VF not going to be shared VF1, and insert the bomb traffic allow. Intersite bomb traffic allow. We're going to uncheck it. Then we're going to add a new subnet, gateway IP. Click OK. At this point, there are no EPGs that are shared across sites, so the web app application profile hasn't been configured under the San Fran and New York template. So we're going to save the schema. Ensure the San Fran and New York template is selected, and we're going to create a new item, new object. It's the application profile. The display name will be a web app. Be careful of the uppercase and lowercase. So application profile name is a case sensitive, so be consistent with the name used previously. Add EPG will be bridge database DB bridge domain. Select the BD DB BD. Next, we're just going to save the schema and click deploy sites. It tells me what are created. Application creating a web app, application EPG, database, bridge domain, database, bridge domain. Click deploy. Now we're going to verify this in my San Francisco APIC. I'm seeing the database EPG is created. Check again in topology. I'm seeing here database EPG is created. Can verify the same thing in New York. Database actual database EPG is created. So this is how you create a common bridge domain across multiple sites and a subnet EPG database in 2 sites, and bomb traffic is banned between these sites. The next topic we'll talk about is import tenant configuration from the site. So this is an important use case because it will be deployed in migration scenarios where ACI has already been deployed in our fabric, and now there's a requirement to connect the existing fabric to a new greenfield ACI environment using the Nexus dashboard orchestrator NDO. So this implies that the ACI Multisite Policy Manager will be inserted in the deployment, and both sites will be added to it. So use this steps will to import the existing configuration for a tenant or from a brownfield ACI fabric, and stretch these objects that are associated to that tenant, like application profile with corresponding EPGs, bridge domain, VRFs, and towards the one or more greenfield ACI fabric. So in this lab, the brownfield sites in San Francisco, and new greenfield fabric is in New York. In the APIC for San Francisco, and we're going to click tenant and brownfield. Click the tenant brownfield. We'll find the VRF under networking, bridge domain, and the application EPG, brownfield EPG. So we'll return to my NDO. We're going to click the orchestrator, click application management. Under tenant, we're going to add a tenant. In the display name here, we'll name it brownfield. We'll select both San Francisco and New York. So let's save it. So this is critical that the name of tenant created in NDO matches the name of the tenant in the brownfield fabric from where the configuration should be imported. The newly created tenant should be associated to both existing sites since the configuration will be imported from one and stretched towards the other. Click application management, check schema, or create a new schema called migration schema. So this new schema will be used to perform the import of the configuration from San Francisco into new migration template. Click Add. We're going to add a new template. But still, we're going to choose the ACI Multi-Cloud. Under tenant setting, we'll pick up the brownfield. Save schema. Now the import button appear under the template priority. We choose import and I will select the San Francisco to import a brownfield tenant configuration into Multisite Manager. We're going to pick AP, application profile, click import. Now we're going to select the brownfield bridge domain to verify the configuration isn't stretched, which is expected since it's imported from a specific site. So, and check inter-site bomb traffic allow box to ensure the bomb traffic isn't allowed. Check the template again, and we're going to name the template migration. Template. Now we're going to associate the migration template to New York site. And we'll click OK. So on the top menu, we'll save the schema, and we're going to deploy to the site. Click deploy. Go to my APEC, New York. I'm finding the brownfield tenant created. Go into it, and we'll find application profile. Brownfield EPG is created. We have a template already created from the template. So this is everything about Cisco Nexus Dashboard Orchestrator NDO with ACI Lab in Multisite, and we talk about how to create a new site, creating the tenants, creating the templates, the schema, and we'll talk about 4 use cases. First one is L3 only communication across sites for intra-tenant and intra-VRF. Next, second one, layer 3 only communication, also cross-site MBF, but it is shared service. Remember the DNS. And next, the IP mobility cross-site to stretch the bridge domain for database without bomb forwarding. And next, we import the brownfield tenant configuration from one APIC, San Francisco APIC, and import it, deploy it to the New York APIC site. So, thank you for watching. If you like my video, please click subscribe button and like button below. If you have any question, leave your question below. I will answer you as soon as possible. Thank you.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget